There is a $4 circuit you can build in 20 minutes that triples the lifespan of any lead-acid battery. Car batteries, solar storage banks, marine batteries, golf cart packs, RV house banks. One circuit, connected once, running permanently in the background. This is not a new battery, not a fancy charger, and not a branded product. $4 of components from any electronic supplier, a transistor, a capacitor, a resistor, and wire, wired into a simple oscillator that sends electrical pulses through the battery at a specific frequency. PulseTech, the company that supplies this technology to the United States military, documented a threefold increase in lead-acid battery life in independent testing. The US Army has used pulse desulfation on its vehicle fleets since the 1990s. The technology has been proven in lab tests, field tests, and government procurement programs for 30 years. A new car battery costs $150 to $300. The average American replaces theirs every 3 to 5 years. A $4 circuit that triples that lifespan, 9 to 15 years instead of 3 to 5, saves you $300 to $600 over a decade on a single battery. Big Battery knows this. They have known it since the 1990s. They have never once told you. This is buried formula. Today we open the vault. They prayed you'd never find. To understand why this works, you need to understand what actually kills a lead-acid battery. It is not age, it is not deep discharge. The primary killer, responsible for roughly 50% of all premature lead-acid battery failures, is sulfation. Here is what happens. When a lead-acid battery discharges, lead sulfate crystals form on the battery plates as part of the normal chemical reaction. Under normal conditions, regular use and proper charging, those crystals dissolve back into the electrolyte during the charging cycle. But when a battery sits partially discharged, or is chronically undercharged, or is stored without maintenance, those crystals harden. They grow. They coat the lead plates in a thick, insulating layer that blocks the chemical reaction the battery depends on. The battery loses capacity. It accepts less charge. It delivers less power. Eventually, it stops working entirely, not because the plates are worn out, but because they are buried under hardened lead sulfate that a standard charger cannot touch. This is sulfation. And for most of the history of the lead-acid battery, invented by French physicist Gaston Plante in 1859, it was considered irreversible. Once the crystals hardened, the battery was dead. Then in the 1980s, researchers discovered something that changed the equation entirely. Lead sulfate crystals have a resonant frequency. When you send electrical pulses through a sulfated battery at the right frequency, 2 to 6 kHz, the crystals vibrate, they break apart, they dissolve back into the electrolyte. The plates clear, the battery recovers capacity. It was never supposed to recover. This is pulse desulfation. The physics is real, the chemistry is documented, the results are reproducible, and it works with nothing more than a simple oscillator circuit that generates the right frequency. The components cost $4 at any electronics supplier. In 1994, a Texas company called PulseTech Products Corporation filed patents on pulse waveform technology for battery maintenance and began selling commercial desulfation devices to the United States military. The results from military deployments were unambiguous. Vehicle batteries treated with pulse technology lasted significantly longer than untreated batteries. Maintenance costs dropped, and replacement cycles extended dramatically. By the early 2000s, PulseTech was supplying desulfation units to the United States Army, Navy, and Air Force. Independent testing documented battery life extensions of up to 3 times normal lifespan. The technology worked, the military knew it worked, and they kept using it. Here is what the battery industry saw when they looked at those results. A technology that triples battery lifespan cuts replacement sales by 2/3. Johnson Controls, which manufactures roughly 1 in 3 automotive batteries sold in the United States, generates over $22 billion in annual revenue. Exide Technologies, East Penn Manufacturing, and Clarios collectively control most of the remaining market. Their entire revenue model depends on batteries dying on schedule and being replaced. The pulse desulfation circuit itself cannot be patented in its basic form. The underlying physics of resonant frequency and crystal dissolution is prior art, documented in academic literature. You cannot build a monopoly around a $4 oscillator circuit. So the industry did what it always does. It ignored the technology for the consumer market, kept selling replacement batteries on the same 3 to 5 year cycle, and let the knowledge sit in military procurement documents and electronics hobbyist forums where most people would never find it. The global automotive battery market generates over $50 billion per year. Every year that the average car owner does not know about pulse desulfation is another year of on-schedule battery replacements. That is the business model. You are the customer. The battery dying is the product. A standard 12-volt car battery costs between $150 and $300 at retail. The average American replaces their car battery every 3 to 5 years. Over 20 years of car ownership, that is 4 to 7 battery replacements, which amounts to $600 to $2,100 spent on a component that pulse desulfation could make last 9 to 15 years instead. The components for a basic pulse desulfation circuit are one NPN transistor at 50 cents, one capacitor at 30 cents, one resistor at 10 cents, and wire and a connector at $2. Total, under $4. Connected once to the battery terminals, it draws minimal current and runs permanently. Commercial pulse desulfation devices, the branded versions of the same circuit, sell for $30 to $150 at automotive retailers. PulseTech's military-grade units run $200 to $400. They contain the same fundamental oscillator circuit. The markup exists entirely because the consumer market was never told the underlying components cost $4. Over a single battery's extended life cycle, that $4 circuit saves $150 to $300 in avoided replacements. Over 20 years of car ownership, the saving is $600 to $2,000 on car batteries alone, before counting marine batteries, solar storage banks, or any other lead-acid application in your life. This is a basic pulse desulfation circuit. You need 4 components from any electronics supplier, Mouser, DigiKey, or a local electronics store. 1 2N355N PN power transistor, 100 microfarad electrolytic capacitor rated at 25 volts or higher, 1 kilo resistor, and hookup wire with battery clips. The circuit works as a simple relaxation oscillator. The capacitor charges through the resistor until it reaches the switching threshold of the transistor. The transistor fires, discharges the capacitor into the battery as a sharp electrical pulse, then resets. This cycle repeats thousands of times per second, generating the high-frequency pulses that resonate with lead sulfate crystals and break them apart. Wire the positive battery terminal to the collector of the transistor and to one leg of the capacitor. Wire the resistor between the positive terminal and the base of the transistor. Wire the other leg of the capacitor to the base. Wire the emitter of the transistor to the negative battery terminal. That is the complete circuit. It draws less than 50 milliamps, a negligible battery drain, and runs continuously as long as it is connected. Connect it to any flooded lead-acid battery, car, marine, deep cycle, golf cart, or RV, and leave it permanently attached. On a sulfated battery already showing reduced capacity, allow 4 to 6 weeks for the crystals to dissolve and capacity to restore. On a healthy battery, connect it immediately and the sulfation never builds in the first place. One honest limitation. This circuit works on flooded lead-acid batteries. Our GM and gel batteries require lower pulse amplitudes, and they need a modified circuit with a lower value resistor. Lithium batteries use completely different chemistry, and this circuit does not apply. If you are unsure of your battery type, check the label. It will specify flooded, AGM, or gel. Also worth stating clearly, this circuit does not reverse physical damage. If battery plates are cracked, corroded, or have shorted cells, pulse desulfation cannot fix that. It addresses one failure mode, sulfation, which is responsible for roughly half of all premature failures. On those batteries, the results are dramatic. On batteries with other damage, it will not help. Gaston Plante invented the lead-acid battery in 1859. Pulse desulfation was documented and proven in military field testing by the 1990s. The United States Army has been using it on its vehicle fleets for 30 years. The global automotive battery market generates $50 billion a year. Every battery that lasts 3 years instead of 9 years is another sale. That is not engineering. That is a business model. $4 of components, 20 minutes to build. The battery in your car could last 3 times longer starting tonight. Subscribe. We open one of these vaults every single day. This is Buried Formula.